right, the unit sound standard 9 part 4 class 9 question number 1. Identify the diagram and study the diagram and identify solid medium, liquid medium and gas medium. Mediums A, B, C. Speed of sound given 1500 meter per second, B 6000 meter per second, C is 332 meter per second. A is liquid, medium speed 1500 water. B is solid, maximum because the molecules are tight, and C is air. The density of the density is lowest, so it is also lowest. Question number 2. Study and answer the following questions. Mediums, they are very short questions, logical. A 332 meter per second. B medium 1270 meter per second. C 258 meter per second. Which medium has the highest frequency and the lowest frequency? Question number 1. Question number 2. What is the relation between sound speed and air density? Just studying the diagram, which medium has the highest frequency? We know frequency and speed are directly proportional. So highest frequency, if you take speed or if it is hertz, it is better to write here highest frequency B, because the speed is highest frequency, and lowest frequency is C, because if you consider speed constant, that is highest frequency, but it is better to write this as if you say the question like this, mediums, and you have to write frequency, wavelength, suppose this is 0.03 meter, 0.04 meter and 0.02 meter. Among them, see, wavelength, consider speed is constant. Which medium has the highest frequency? For highest frequency, the wavelength should be lowest wavelength, highest frequency, and highest wavelength, lowest frequency. So the answer is question number 1. According to frequency is inversely proportional to wavelength. So which medium has the highest frequency? 0.03, 0.04, 0.02. This is the lowest wavelength, shortest wavelength, highest frequency. So which medium? C has the medium C has the highest frequency. As wavelength is minimum. Wavelength is minimum, so it has highest frequency. Another, what is the relation between sound speed and air density? Sound speed P is inversely proportional to the square root of the density D of air. That means mathematically B sound speed is inversely proportional to the square root of the density. When density increases, speed decreases. When density decreases, speed increases. Question number 2 finished. Question number 3. Question number 3. Written question that you have to answer. Mention some characteristics of sound wave. What are the characteristics or features or natures of sound speed? Sound speed को अथवा साउन्ड वेव को क्यारेक्टरिस्टिक्स प्रपर्टी के होला हुन सक्छ के गर्छ त साउन्डले some features or characteristics of the sound wave are as follows. What is the first one? Sound go. It is mechanical in nature. Means it needs a material medium to travel and can't travel through vacuum. Its speed in vacuum is 0. It cannot travel in vacuum. Another is it travels longitudinally in the forms of compression and rarefactions. It travels in the same direction as the particles of the medium and it travels in the forms of compression and rarefactions and it affects ears. Another, its speed is directly proportional to the square root of the density for solid and liquid. For solid and liquid, the speed of sound is directly proportional to the square root of the density of the solid and liquid. Solid र liquid को density सँग यो के हुन्छ directly proportional हुन्छ. For solid and liquid, when density increases, sound speed increases. When density decreases, sound speed decreases. But it is inversely proportional to the square root of the gaseous density. For the gas, the speed of sound is inversely proportional to the square root. For example, hydrogen 1258 meter per second. Hydrogen, air medium 332 meter per second. Carbon dioxide 258 meter per second. Carbon dioxide has more density, so the speed is less. Air has medium density, so the speed is also 332 in between. Hydrogen has lowest density, so the speed is highest 1258 differentiate among the three given. They are some of the characteristics of sound. Another, some numericals. Question number 4, some numerical. Before solving, you have to know this formula. V equal lambda f is bt by 2 or is equal bt by 2, frequency 1 by time period, and t equal 1 by f. That is the formula. So let's solve some questions. Some questions are as follows. Question number A, see, time period given, find out the frequency. Time period, find the frequency of a wave whose time period is 0.01 second. That means in 0.01 second it makes one complete vibration. In 1 second how many? That is the thing. Time period 0.01 भएको 01 सेकेन्ड भएको वेभको फ्रिक्वेन्सी कति होला? सोलुसन, this second, this is time period. Time period capital T equal 0.01 second. Time to make one complete vibration. What is frequency? F equal what? We know. Just by the definition, F equal 1 by T. Frequency is the, what is frequency? Number of complete vibrations made by a body in 1 second. 1 upon 0.01. Using a calculator, it is 100 Hz. Use a calculator, 100 by 1, 100 Hz. Frequency, SI unit, Hz. Question number A. Question number B, I just write down, see, velocity given, frequency given. Find the wavelength of a wave traveling at 332 meters per second if its frequency is 100 Hz. Frequency is 100 Hz. What is the wavelength of a wave traveling at 332 meters per second? This is speed v. Frequency is given. Speed is also given. What is the wavelength? Given condition. First of all, given condition. Find the wavelength of a wave traveling at 332 meters per second. Speed, that is, speed of sound is 332 meters per second. SI unit of speed. Frequency, F is 100 Hz. What is wavelength? Wavelength, lambda equal what? We know. Lambda equal V by F. 332 by F 100 meter. 1 to 1, 3.32 meter is the wavelength of a wave. Lambda d by F. F d by lambda. B lambda F. Where V for speed, F frequency, lambda wavelength. Question number 4B. Now 4C. Question number 4C. Let me write down the question. Similarly, we can also write down other questions as well. Find the speed of sound if its wavelength is 100 centimeter and frequency is 1 kilohertz. Okay, if it is kilohertz, you have to change into hertz. Megahertz, 10 to the power 6 hertz. Centimeter, change into meter. SI unit. Or always remember MKS system for class 8. Solution, find the speed of sound. Wavelength is, what is wavelength? Wavelength lambda 100 centimeter. 100 by 100 meter by SI system. Wavelength given. Frequency is also given. Frequency F equal 1 kilohertz. 1 into 1000 hertz. 1000 hertz. Wavelength lambda centimeter change into meter. Divide by 100. Frequency kilohertz into 1000. If there is megahertz, 10 to the power 6. 10 lakh. What is the speed? E equal what? We know E equal lambda. E equal lambda F is the formula to find the speed of sound. Lambda is 1 meter. Frequency meter per second. Hertz. That is 1000 meter per second. Or since it is 1000, you can change into kilometer per second. 1 kilometer per second. The speed is 1 kilometer per second. In 1 second, the wave travels 1 kilometer. अर्थात 1 second में 1 kilometer उतारले तो speed गइरहेको छ. Another is also given. Say what is given is time period given, speed given, find the distance between them. A, B, C, D. But time period is given, speed of sound is also given, find the distance between them. Find the distance between 2 points if the echo of light is heard in 2 into 10 to the power minus 5 second. The echo of light is heard in is per second. Light is heard. Light is heard or felt. And its speed is 3 into 10 to the power 8 meter per second. The speed of light is 3 into 10 to the power 8 meter per second. The echo of sound anyway is found in 2 into 10 to the power 5 second or recorded. The echo is recorded, felt or recorded in 2 into 10 to the power minus 5 second. Find the distance between 2 points. What is given? The solution is this. This is time period t in 10 to the power minus 5 second. Speed v equal 3 into 10 to the power 8 meter per second. Distance what? We know distance equal vt by 2. Why 2? Time to go and time to come back. यो डबल टाइम हुन्छ त्यसरी vt by 2 गर्नुपर्छ. यदि टाइममा आएको V velocity 3 into 10 to the power 8. Velocity V. T is 2 into 10 to the power minus 5 by 2. To cancel 3 into 10 to the power 8 minus 5. 3 into 10 to the power 3 or 3, 1, 2, 3 meter. 3 kilometer. Divide by 1000. What is the distance between them? 3 kilometer. Time period given. Velocity given. Distance what? See, this distance is A to B and B to A, back. The formula is Vt by 2. Velocity into time by 2. To cancel. 3 into 10 to the power 8 into 10 to the power minus 5. Law of index. 8 minus 5. Then you can solve. 3 into 10 to the power 3. 3000 meter. 3 kilometer. Divide by 1000. Question number D. Question number E also. Question number E. In the same way, you can solve one question which I give. A dog has a hearing range from 67 Hz to 47 kilohertz. Find the maximum and the minimum wavelength of a wave which can be heard by it. See, if you need a calculator, you can have it. Use calculator. Solution. A dog has a hearing range from minimum 67 Hz to maximum 47 kilohertz, not Hz. See, what is this? Minimum frequency. F min is 67 Hz. Maximum frequency given F max. What is given? 47 kilohertz. 47 into 1000 hertz. 47000 hertz. Change into the SI system of units. And consider speed. Speed of sound is 332 meter per second per second. What is the minimum wavelength and maximum wavelength? Minimum frequency, maximum wavelength. Maximum wavelength lambda max. What? Minimum wavelength lambda min. What? You have to know that lambda is inversely proportional to frequency. To get minimum wavelength, there should be maximum frequency. To get minimum wavelength, maximum wavelength, minimum frequency. We know lambda max equal V by F min. To find maximum frequency, minimum wavelength, and maximum wavelength, मिनिमम फ्रिक्वेन्सी। म्याक्सिमम वेभलेन्थ निकाल्नको लागि फ्रिक्वेन्सी मिनिमम हुनुपर्छ, मिनिमम निकाल्न यो म्याक्सिमम हुनुपर्छ, इन्भर्सली प्रोपोर्सनल। भी 332 एन्ड एफ मिन इज सबभन्दा सानो कति छ 67 छ, ल्याम्डा म्याक्स मिटर। नाउ आई विल सो यु हाउ यु हेभ टु सल्भ 332 by 67। आई सो 332 divide by 67, 4.95 meter nearly. Here I have written only 2 points after the decimal, about 4.95 meter. And lambda mean minimum wavelength कति हुन्छ v upon f max। frequency maximum, wavelength minimum, frequency minimum, wavelength maximum। v is 332, maximum wavelength is 47123 meter। 332 by, see I'll show you, 332 by 47,000, 332 divided by 47,000, see 0.0071, 0.0071 meter nearly। When frequency is minimum, wavelength is maximum, and the maximum wavelength is 4.95 meter। कुकुरले 4.95 meter long distance को वेभ पनि सुन्न सक्छ, साउन्ड वेभ सुन्न सक्छ। भने मिनिमम उसले सुन्न सक्ने चाहिँ भेलोसिटी बाई फ्रिक्वेन्सी म्याक्सिमम 0.0071 मिटर, अर्थात् यसलाई हन्ड्रेडले गरेर 0.71 सेन्टिमिटरको एकदम स्मलेस्ट मिनिमम wavelength 0.0071 meter and maximum wavelength is 4.95 meter can be heard by the dog। यो कुकुरले सुन्न सक्ने चाहिँ यो हो। We know dogs and cats can hear ultrasound, whales, crickets, etc. can produce ultrasound। What is the machine to produce ultrasound? Fathometer or echometer? Fathometer or echometer can produce ultrasound। Remember, this was for today, and practice more for best of luck for your PLE, Personal Level Examination. Okay.